Okay, so today we are going to learn to create a FCM bridge. So FCM bridge is just a free cantilever method. So it's just like a method to erect a bridge to the top of the pier. So, and we are going to create them using template, a smart template from CIM here. So, okay, as you can see in here, when you click the template, you will see the array of option in here. Okay, you can see there's a PSC beam bridge, FCM bridge, or free cantilever method bridge, full span method bridge. So this is just the difference of how to erect the span bridge to the top of the pier. So yeah, and cable stayed bridge, suspension bridge, and there is also tunnel in here for the smart template. And today we are going to create the template for FCM bridge. Okay, you can just click on the picture. Okay, and as you can see, there are 4 tabs in here: general, layout, model, and tendon. So general is just like the template name. You can create the template. So this template name will be the name for the assembly unit. So the product, the output that this application will create is assembly. So as you can see in here, assembly. So this assembly will have a lot of curve library and also a lot of point library, which you can see in the object in the tab on the workstream that you can in the future see. Okay. So you can see here the template type is assembly unit, and this case, this is the run modify mode after creation. As you know that if you want to modify your assembly unit, you will have to go to your workstream and right click and then click modify, right? If you click this on, take this option on, you can automatically see the after you create the assembly, you will automatically modify your assembly unit. So it's better to take on this option. Okay, moving on to the layout. You can see that in here the layout they have many other parts. So as you know, this is number of peers, the set of the peers that you want. For the template support, you can create them up to 10 or 11. So, but in this case it's 10. And there's also a peer table support. So if you want to set the top and bottom connection method, either fix or pairing for the connection, the boundary link. And in here, the first case is the peer table. So you have you can click on advanced if you have a specific dimension that you want. So as you can see here, in the maybe if you have 4 peer, then you will have a zone 1 and zone 2. So you have a 4 zone 1 and 4 zone 2 if you have 4 peers, and you can modify each type of them to the one that you desire. So maybe the first peer, the second peer, third peer, and fourth peer will have a different dimension. And for the key segment, again, of course, if you don't have that amount of details, you can just take off the advanced and just go ahead with the dimension of one single peer, and it will be copied to another peer, to the other peer. So as you can see here is PT, the peer table width is 10 meter, is this from this part to this part, and the P is the core width of the top of the peer table. And moving on to the key segment. So key segment is just the number of section segment. So you can also see this one is K1, K2. In the picture is K1 and K2 is between the FSM zone and the zone 1. So the FSM zone is usually is located in the apartment. So the first point and the end point of the bridge. So this is just the FSM zone. And you can also click advanced if you have a lot of peer with a different width. Okay, and you can click on FCM zone, and this FCM zone is just if you want a lot of segment in your tapered section. So for example, as you can see here, this is section 1, section 2, and section 3, and the rest of them is the tapered zone. So if you want to change them, for example, you can just change this one. So if you change this number, so for example, this is the first number, this will be the number, the width of this zone 1 in section 1, and the second number will be the width of the second number in zone 1, and so on and so forth. So if you click on 2, 3, and then 5 meter with a quantity of 10, then you can see that it will be 2 meter, 3 meter, and then 5 meter, 5 meter, 5 meter, 5 meter until K1 in here. Same goes to the zone 2 in the right hand side. And FSM zone is also similar. The important thing is that, as you can see, the one, so the sequences starting in terms of the FCM zone, starting from inside the peer table. So 1, 2, 3 is from the peer table, but as you can see in the FSM zone, the 1, 2, 3, and so on is starting from the outside of the bridge. So this is important if you want to make sure that the details that you inserted in your project is correct. And then finally is the end zone. So the end zone is also expansion joint length of the starting point in the diaphragm thickness. So this is just an expansion joint. So it doesn't, it is not seen in this picture because this expansion joint is just the in between of the bridge. Okay. Okay, moving on to the model. You can see this is just like a section, the section of a segment of a bridge. There's a deck slab with the girder deck width, girder, and this is the pavement thickness, the road pavement thickness, and this one is the offset between the alignment center. So this is the alignment center, the middle, and if you have an offset, so if you have a space between the center to the first lane, then you can enter this. But in this case, we don't have any offset, so you can just click it to 0. If you want to have no space at all between the alignment middle, to the structure center, you can click 0. And this one is similar to the picture, spacing L1, Alt L2, L3, L4, and L5 in here. And as you can see that the L2 is fixed. Why the L2 cannot be changed? It's because it's automatically inputted. So the L2 consists of the entire road width minus the median strip, so the median strip of this one, and the left barrier, and also the right barrier. So this is just automatically calculated from the deck width. Okay, so you can see here, the type L3 is the median strip, left barrier, right barrier, road, and road. And in the section, you can change a whole lot of dimension in here. So this number is representative to the dimension of each section in the picture. And the bearing settings, you can change the spacing and the location of your bearing. The haunch length, so the haunch length is just like the tapered section, the edge of the tapered section. As you can see, the tapered section has a different edge instead of just one corner in here. They have a two corner in here, and you can determine the length of each corner in the overall haunch in here by changing the number. And for the substructure is similar. If you want to change either the first support is the abutment or another pier. So if you want to calculate maybe an extension of a bridge, or if you want to create a new bridge. So yeah. And lastly is about tendon. So if you can create tendon, you can create tendon, or you can just leave this button off. If you click this button on, however, you can see the location of each tendon that you want to insert in here with the tendon number and the tendon property based on the database that we have, anchorage type, and the database properties with the number of strands and strands diameter. And the anchorage, you can also determine the anchorage. Okay. Okay, so in this case, we will be creating the assembly unit using small template, and then after that we can create a layout to which we can insert this assembly unit to the layout, and then we want to connect the creation of this CIM to the Midas civil. Okay. Today we are going to create a 5-span PSC box bridge with a total length of 566 meter with a specification of 88 meter for the first span and for the end span. So we will have 4 pier, okay, similar with 88 meter for the first pier, for the first span, and then 130 meter for the next tree span, and then the other one is the 88 meter for the end span again, with a bridge width of 16 meter, with a girder height of 3 to 7 meter of the side section, with a tendon of 19 strand 15.2 millimeter for the top side, and the bottom side is 12 strand with a 15.2 millimeter. And for the FSM section, it will be similar, the 19 strands 15.2 millimeter. Okay, we can start with the creation of the name. Of course, the creation of the name will be the FCM, and then we can go to the layout, and we want to create the first one is to change the FCM zone. So the segment zone here, we want to change this to 2 at 2, and because this is already 4, and we want to add 11 in here. Okay, 2 at 2, and this one is 11. Okay, and then we want to change the expansion length and joint length in the end zone to become 0.5 and 0.5 for the start and end. Okay, and now moving on to the model tab, you can see that we want to uh, keep this section similar, but of course this depends on your project. You can change all of them using the this value, and then to the tendon tabulation, you can click on the create tendon, and then in terms of the tendon property, you want to change to VCL, VSL, with the anchorage type of plate, and with a version of F6-19, sorry, E-19, with the FCM of similar VSL with a plate and E6-19. And for anchorage, you can also see that the location anchorage number is matching, and after that you can just click on create assembly unit and wait for the process to finish. Okay, as you can see, after we take on the run modify mode after creation, the one that is in the smart template, you can see that we automatically are inside the assembly unit modifying mode. As you can see, we have a lot of object in the structure member here with the individual subject, and also the entity. As you can see, there's a lot of constraint plane and etc. You can just click OK, and then the next step will be to create a layout. As you can see, you can just click in here, base, layout ribbon, and click layout and create edit, and then you can click new here, and you can change the layout to FCM bridge layout. Okay, and for the alignment here, as you can see, they have three alignment in here. Sorry, three dot like this, and you can add as many as you want, but in this case we can add 4 more. As you can see, the total is 7 point here, and you can change maybe the first one is straight with a length of 90 meter. The second one is arc. So the arc is just a curve in that location. And then if you want to check clotoid is just like a spiral, and cubic parabola is also, if you have like a not a full circle, so yeah, usually we only use a strike and arc for the layout purposes. And in this case, if you click arc, you will have a length, and also you have a radius. And as you can see here, if you click clotoid, you only have RS and RE. And if you click on cubic parabola, you will have the same as well. Okay, in this case, it will be 130 with a radius of 500 millimeter. And the next one will be arc as well, 130, radius of 500. Next one is straight and straight. Strike, arc, strike, strike. Another option is to check on the vertical alignment, and we want to change the station. The first station is to 0 with the elevation of 570 meter. Oh, sorry. So the station will be station 0, and then the second station will be 570, because as you can see, the total length of this is 530 with the maximum station of 570 meter in here. So the vertical alignment will be station 0 to station 570 with the length of from 0 to 5.7. As you can see, it's a increasing vertical to the top. And you can also add, if you have a different segment. So if you have maybe a lot of segment, you can add the segment in this part. You can click in here, And then if you have also a super elevation, so change of angle of each road. So if you have a left banking, you might want to increase the super elevation in the right side and decrease the super elevation in the left side. Okay, so if all of them are in the working order, you can just click on OK. As you can see, the layout is already created in here. And then the next part will be to assign the assembly unit. So to do that, it's just to click on assembly. Because we already create the assembly from the template, you can just click assign. And as you can see, this is the assembly that you have created. So in this case, you only have created the FCM. And because we chose only to change the station layout, so we don't change any segment, we can just click on the whole layout and select layout. In this case, we have created the defining path, and then we can just click add. Okay. And you can also click if you want to create your assign your assembly unit from the end. You can click on from end. And in this case, if you have super elevation, so you will have um, different height in each of your layout. So for example, if you have like this, the layout is in from the straight to the arcing to the right. In normally in road you will have a super elevation. So super elevation will be looking like this. In that case, you might want to click on alignment tangential. So in this case, the angle that the layout provide will the assembly will follow the angle of your assembly if you click tangential. But if you click parallel, then it will be a constant angle, the way that you assign your assembly. So keep in mind if you have angled structure. But in this case, we will have parallel. And you can click on preview first if you want to check whether or not the assigning process is correct. Okay. As you can see, the parallel keep the angle similar between them. Okay, and then just click OK to apply. Okay. And if you want to see the tendon inside the model, you can just easily click on the option mode in here, option ribbon, and click view. Similar to the last class, we can see in here, you can click on transparency, and you can click on the concrete member and click mono, and you can either click on 0.2 or 0.1. It's okay. As you can see, the tendon inside is visible. And if you want to maybe make the still transparent too, you can do so in this case. Okay. Yeah. So as you can see, now we would like to assign the tendon here as a tendon group. So in this case, we want to click on front and just click on the select the peer and then hide them. Don't forget this one. Okay, so after you only see the span in this, you can click on the work tree and click on object, and you can search for the tendon group. As you can see here, the tendon group is only one, but it contains all of the tendons. You can right click and you can assign member. Then you can just name the tendon to tendon group 1 maybe, with the reference member of all of this. Then click OK, and then show all. Okay, next step will be to create the rigid link. Okay, so in this case we want to see the first part. The first part will be this abutment area, and you may want to see this part only. As you can see here, you may want click on this and click show only, and okay, if it's bothering you, you can just click on layout to, yeah. Okay, now you can see in here and click model. You can see that there's a boundary in here, right? In the analysis ribbon. You can click on the boundary and you can click on the rigid. Okay, in this case we want to click on rigid link from vertex to 1D member. So in this case we want to select the vertex. The vertex is the point in this one, 1 and 2, and we want to connect them with the 1D member of this part. And of course the master point will be the one in the 1D member. So you can click on the 1D member and you can click apply. In this case you have a rigid link and you can click show all, and you can see the rigid link in this particular part, and you want to add another rigid link to the other properties, sorry, the other peer table. Okay, so moving on, if you want to add another one, you can just click here and right click, and you can click show only, similar to last one, and then just do the similar thing. Click on boundary, rigid link, and vertex to 1D member. But the difference, the vertex is only 1, and the 1D member is 1 as well. Okay. And you want to change them to all of the rigid link. Oh, sorry, or the peer table. You can of course just click on this, sorry, just click on this part and click on another one and click on the last one. So that you can just click show only and then create the rigid link. Keep in mind that in the apartment you will have 2 vertex and 1D member. Okay. And then we are going to create the elastic link. So the elastic link will be in the start part and the end part. And to do that, it's just similar to last one. We can just isolate this part. You can also isolate the end part. And just click show only and click on the boundary and click elastic. So click on the first vertex and the end vertex with the line type of general, and change the stiffness to 265,8996 kilonewton. Okay, so you have to be You have to be careful, okay? If you have a Newton, you have to choose this to kilonewton. So this one will be 265,996 kilonewton per meter, and for the dy will be 7547 kilonewton per meter, similar to dz. And for the rx, ry, and rz will be 0 because we don't want rotation in the stiffness. And then just click OK. And for the next one will be similar. Okay. Now we have the rigid link and elastic link, and now we would like to add define the support. Okay. Okay. So to make it easier to create the support, you can just remove the general member in here. Okay, wait. As you can see here, there's a lot of member. Make it easy, you can just unseen this one and unseen this member and unseen the steel as well and unseen this tendon and also maybe unseen the pile cap. Okay, and in this case we have the vertex in this apartment, and also we have the vertex in every pile cap. Okay, and just the way to do it is just click boundary and click support, and then for the target you can just be careful to click the vertex point in this case. And then vertex point in each of the file cap, and also vertex point in the last part. Okay. Okay, so after you have create the boundary, the rigid link, elastic link, the support, you want to create an analysis case. The analysis case which can be exported to the Midas civil in here. So to do that, you can just click analysis case. Okay, as you can see, all of the concrete member will be transparent, and but the tendon and also the boundary. And you can click on the define here. And as you can see, we can name the analysis case. In this case, it's just analysis case 1. And then we can determine the 1D element. So the 1D element will be all of the member that you have. In this case, don't worry. You can even though if you select all of them like this, the 2D element is the one that is selected. So as you can see, this one is only 47 2D, 47 1D element is selected, but the boundary condition is not selected. So vice versa, if you click on boundary condition and you click all of them, only the boundary condition that is selected. Okay, and for the analysis case, you may want to change the mesh size to length and 1 meter. And 2D is not important because we only choose 1D and boundary condition, and then click OK. And this analysis case will be available in the Midas Civil. As you can see, to open the Midas Civil, we will need the analysis case. In this case, this one. Okay, so this analysis case has been defined, and you can click OK in the analysis mode, and just click on the Midas Civil in here, and you can choose either to run Midas Civil or Midas Civil NX. In this case, we can run with NX, and we can we can select the analysis case that we have been created. Okay, and it will automatically open the Midas Civil NX. Okay, forgive me. So we can just click on the run and Midas Civil NX, and then click on the analysis case, and then click apply. It will prompt you to create the Midas Civil NX opened by administrator. So the last one, the fault is that I have my account run in another computer. So because one license should be used by one computer, so that's why I have to log off my first computer. Okay, as you can see, the created model is imported in this case, and as you can see, the mesh is 1 meter in each direction. So yeah, as you can see, they have a lot of segment. Again, this segment can be created using the analysis case. Okay, if you want maybe a division, maybe for example, if you have some point in this middle and this middle, and you want to only partition the segment to maybe 5, you can just create them, or in this case, you want to only create the section of 1 meter each, you can do so as well in this case. Okay, as you can see, all of the material, all of the sections is already here. Okay, and you can see all of the tapered section group and all of the rigid link, elastic link, and the support, and also the tendon profile, as you can see here. Okay, so that's all that we have time for the template. Again, all of the details can be seen in the cim.refine.site okay. as being shown in this case, as you can see here in the cim.refine.site here. You can click on the smart template in the CIM manual, and you can see there are in this case you want to click on bridge template function, and if you want to check the maybe the guidance of what each value in the smart template is for, you can just click on maybe in the FCM bridge, and you can see all of the information regarding each what each button uses for. You can do so in here. You can also click on advanced if you are still confused regarding the value in here in the key segment. Also there's an advanced and etc. And if you want to change to another bridge, you can just do so by clicking here and etc. Okay, so thank you everyone.